Hi, my name is David Johnson. I'm a researcher and software engineer at the University of Utah, and in this video I'm going to give you a brief tour of the Powder Platform's user interface and describe how to run and combine several large software stacks on its resources. First, I'll browse to the powderwireless.net website, which you see here, and if I click the Login button after obtaining an account up in the upper right-hand side, I'll be presented with my user dashboard. The first thing you'll see is that I have a number of experiments that are running on the various clusters that make up the Powder Wireless Network testbed. They're each using one or more compute servers. If you click on the next tab, the Profiles tab, you'll see the profiles that you've written. I've written a number of profiles for large software stacks like ONAP and ORAN and Openstack, Kubernetes, and various others. So a profile is a description of the resources, the software that's running on them, and runtime configuration that you want to apply in the context of a running experiment. We're going to look at some more advanced profiles that are themselves Git repositories that contain a script that generates a resource description combined with a number of parameters and contains configuration scripts that are run once those resources are allocated to you to turn them into the software configuration that you want. These are some of the experiments that I have running. Some are ORAN and ONAP experiments and others. So let's go through quickly what the process of instantiating an experiment would look like. So let's say I want to create an ORAN experiment. I want to try out the ORAN software community's near real-time RIC, as I'm going to show in a later demo. So I'm going to select a different profile. I could search, but I can already see in the recent profiles that I've instantiated the ORAN profile. You can see again that this is a repository-based profile, and you can see a brief description that tells you a little bit about this profile. So I'm going to select that, and then I'm going to click Next to create an experiment based on that profile. The second step of this process is to fill in some parameters. This is an advanced profile, and it has a large number of parameters, but the basic ones are that I can choose the number of nodes that I want to be part of my Kubernetes cluster, and ORAN has a smaller number of microservices, so I only need a single node. That will suffice. I can choose the hardware type. I can change network parameters. I can select a specific release of the OSC's near real-time RIC. And I can change a number of other parameters, including how software is built and deployed. You can see that we have versions of SRSLT and OAI that are ORAN E2 enabled. So I can have those built so that I can use them in the context of this profile. I can change network parameters. I can customize my Kubernetes deployment and Docker options and Helm options. I can change the network plugin that's used in my Kubernetes, and a number of other things. So if I then click Next after choosing my parameters, the parameters that I've chosen are sent to the backend, which runs the script that generates the description of resources that I want and customizes it according to those parameters. I give my experiment a name, then I can finally click Next again. Then perhaps I have a reservation that I want to use, or I want to schedule this experiment to start at a later date, and then I would click the Finish button. And that would result in an experiment that looks like this. This is an ORAN experiment that I already have running that was built from the ORAN profile. If I scroll down, you can see that there's a single node, has some metadata as shown in the pop-up, but its state is up and its startup scripts have finished, which means that the software configuration has completed, meaning that Kubernetes has been installed and configured from scratch according to the parameters in this experiment, as has the ORAN microservices. If I click on this node, there are a number of options I can take. I can pop open a shell and remotely access the node from within my browser. For instance, I can take a look at the pods that are running in one of the RIC namespaces. And you can see some of, if you're familiar with the near real-time RIC, you can see some of those microservices right here. If I go back to the topology view, click on the node again, I can access its serial console or the log of that console. I can reboot it. I can reload it with a fresh image, at which point the software scripts would be rerun again, and Kubernetes would be reinstalled from scratch, as would ORAN. If I mess up my disk, I can boot it into an init-ramfs, a memory file system, and examine the state of the disk. And I can power cycle it if I manage to panic the kernel. I can also take a look at the instructions for this profile. Again, this is an advanced profile, and there are a number of instructions, including how to access my Kubernetes web interface, the credentials, that the secure random credentials that were generated to access these resources. We deploy Kubernetes using KubeSpray, which is a collection of Ansible playbooks. And so this gives you some context for how you can change your Kubernetes deployment by replaying some of those Ansible playbooks with different configuration. Finally, there's a large collection of instructions on how to run, modify, and access the ORAN microservices, and how to run things like the network slicing demos and some KPM demos. And we'll show the slicing demo later on in this presentation. I've already clicked on the link to the Kubernetes dashboard and logged in. So I can take a look at some of the RIC microservices that I already showed via command line. But this is just a web view of those, and you can see that they're running and consuming resources right now. Now, you might have noticed in the topology view for this ORAN experiment that my node had a dangling link off to the side. This means that it is connected to what we call a shared VLAN, which is a way to connect multiple experiments together. So not only do I have my instance of the near real-time RIC, I have another experiment that's already deployed that has a collection of Powder's software-defined radio resources. These are NI SDRs. I have 4 B210s that are going to act as UEs, and then I have a single X310 that will act as a base station, a node B, and that's connected to a higher powered server for doing the extra radio processing. And that node is then connected to my shared VLAN so that I can configure my node B software to communicate with the near real-time RIC and run network slicing demos on that, or RAN slicing demos on that. Moving on a little bit, another example of a big software stack that I wanted to highlight is an ONAP experiment that was instantiated from our from our ONAP profile. This is another large profile with many instructions. You can deploy ONAP with different configurations. ONAP is a larger collection of microservices, and in this particular case, I deployed it with a quote, minimal set of microservices that are sufficient to allow me to instantiate VNFs inside of an OpenStack, use the software-defined network controller, and deploy service models from the SDC component. Again, this is a single node experiment because I've carefully curated the set of microservices so that it fits on a single Kubernetes master and worker node combined. The instructions in this case, again, tell me how to connect an OpenStack cluster to ONAP so that this is a useful ONAP instance that can instantiate VNFs. Has the same Kubernetes instructions or similar ones to the experiment that we already looked at in the ORAN context. And there are some instructions on how to interact with the ONAP deployment. As I mentioned, as you can see down in the topology view, there's another kind of dangling link from this single node ONAP installation. And that connects to an OpenStack experiment, which we'll show in just a little bit. But here is the Kubernetes dashboard and the view of the ONAP namespace. Again, there are a large number of microservices that are deployed, and if you're familiar with ONAP, you'll recognize some of these names. I also have access to the ONAP profile. And I could take a look at the virtual infrastructure component. My profile preloads some of the virtual firewall demo service models into this, and so I can click the service models and browse them, and I can click the deploy button to go ahead and try to deploy some of them, and that will bring up a UI that would allow me to deploy these service models. And if that would succeed, then that would result in VNFs deployed inside of my OpenStack experiment. My OpenStack experiment is already here in this example. This has a few more nodes. There's one OpenStack controller node and 4 compute nodes. And again, the OpenStack profile configures its OpenStack instance according to the parameters in the OpenStack profile. And OpenStack is a large software stack, so there are a number of profiles that allow you to change the behavior, like changing its network deployment and its configured plugins, storage, and so on and so forth. And again, I can access the OpenStack web interface, and I can take a look at those at a different view of those same compute nodes that are waiting for VNFs to be instantiated on them over the shared VLAN from ONAP. So the thing that I want to emphasize here in closing is that these are all instances of profiles that support large software stacks, but all of the configuration and deployment has been scripted in most cases from bare Ubuntu 18 images, so that everything can be built from scratch and start fresh every time. And this is a significantly useful feature over static deployments. The ability to quickly script and automatically deploy large software stacks is one of the key building blocks of the Powder Network testbed. So if you browse to the powderwireless.net website and obtain an account, then you can try some of this stuff out. Thanks for watching.